Hello and welcome. This is Organic Chemistry 2 review presented to you by Science Visualized. So this question says provide all the products for the reactions below. And we see the first reaction is a ketone. And when that is reacted with zinc and HCl, that reaction is called Clemmensen reduction. And that basically cleaves the carbonyl and reduces that. So it adds hydrogen to that position. So the product, we start with that backbone, and then instead of the carbonyl, now we end up adding hydrogen. You can achieve the same product by using what's called Wolff-Kishner reduction, where you use KOH and the NH2NH2 that will carry out the same reduction but under basic conditions. Next, we see a Grignard reagent, and when you see a Grignard reagent, this carbon here has a minus charge, so it's a really good nucleophile, and that is either going to add 1, 2, so that's position 1, 2, 3, and 4. So 1, 2, that position, or 1, 4. If it's just a straight Grignard reagent, you get a 1, 2 addition. If it's a Grignard reagent with a cuprate, any type of copper salt, then you end up getting a 1, 4 addition. So for 1, 2 addition, you end up with an alcohol, so OH, and then you add the Grignard reagent. And that's going to be the product for 1, 4 addition, and nothing happens to that alkene, so we still keep it. But for a 1, 4 addition, it adds to this position here, so you end up with this product. But now you have the Grignard reagent added at the 4th position. For this reaction, where we have SO3H, when you react that with sodium hydroxide at high temperature with water, you end up replacing this with an OH group. And you find this under aromatic reactions. Next, we use O3, that's ozone, and that process called ozonolysis. That will cleave the double bond and replace it with a carbonyl. So you end up with this product. So that double bond is cleaved and then replaced with a carbonyl. And then on this side, same thing happens. Next, reaction of an alkyne with water in the presence of an acid, that's H3O plus, in the presence of mercuric acetate. So this is a mercury catalyzed hydration. You basically end up adding H and OH across the triple bond in a Markovnikov fashion. That means hydrogen adds to the carbon with the most hydrogen. So this terminal alkyne carbon, you end up with an alkene product with the H added to that carbon and then the OH to the other carbon. And this product is called an enol, which is not stable, so it's actually an intermediate. And this will go through a keto-enol tautomerism, so KET, to give a more stable product, which is a ketone. Next, PCC, that's pyridinium chlorochromate, in CH2Cl2 solvent, that basically carries out oxidation of the alcohol to become a carbonyl. And because that's a primary alcohol, then it becomes an aldehyde. So that's going to be the product. Next, reaction with thionyl chloride, SOCl2. That's a chlorinating agent, and basically you end up replacing the OH in the carboxylic acid with a chlorine to form an acid chloride. Thank you very much for listening.